Hello everyone. Today our topic is about applying big data methods to analyze difference in severity level of coronavirus among countries. So the coronavirus pandemic has caused a significant negative impact on countries around the world. Take US for example. The confirmed case is already exceed 300,000. Comparing with the World War II, the total deaths caused by World War II for United States is only 400,000. Right now, coronavirus already caused 75% of the loss of the World War II. So that is serious. And this pandemic appears to have a observable difference in severity levels among different countries. This project aims to use big data analytics method to provide insight into roles many social and economic factors played in contributing to this variation. So here is our data source. The coronavirus-related data generally comes from European Center for Disease Prevention and Control, and the economic-related data comes from IMF and Organization for Economic Cooperation and Development. First, we begin with clean and transforming data. So we can say this table explains there exists a considerable portion of missing entries in raw data. That is particularly true for the variables related to new coronavirus test. The reason behind this may be many countries have limited test abilities for detecting patients actively infected with the virus or choose not to report. Since there is no sensible way of filling this missing data, variables with more than 30% of missing values, they are mainly like variables related to new tests were excluded from the analysis. I also did a pairwise correlations, uh, try to check the potential remaining multicollinearities between predictors. Research proposed that 0.85 correlation coefficient could be viewed as a threshold for determining multicollinearities in coronavirus. So from the pink curve, we can say the no two predictors with a correlation greater than 0.85. So that is a good thing. So I do not think multicollinarities will be a significant reduce the precision of our estimate of the coronavirus. And then here's several big data analytic method I use to analyze the data set. I apply both um, unsupervised learning and supervised learning. For the unsupervised learnings, I choose k-means because that is a widely known and is easy to implement it in R. For the supervised learning, I start with the linear regression because it's easy to interpret. And for the uh, deal with the overfitting issues, I also use lasso regressions. And moreover, I also implement the random forest and gradient boost to uncover the potential nonlinear relationships. So first, let's start with the k-means clusterings. So here I use three clusters with the intention to mimic groups with high, medium, and low levels of average death rate, just as shown in the pictures. So the high is shown in the red, and the median is showing green, and the low is showing blue. And we can see there's relatively few numbers of outliers. So it can be observed these k-means in details. So as we can see in these tables, we have several different factors like both social and economic variables, like the GDP per capita, statistic index, and life expectancies. So it shows a considerable powers in categorizing severity crises into three different groups. Higher value of the stringency like index are correlated with a lower death rate. Its correlation is expected as a stringency index measures the extent of the restrictions placed by government in response to pandemic. Tougher measures, such as Strict social dis distancing policies are expected to have a positive impact. Higher and lower income countries, as measured by GDP per capita, tend to experience a lower death rate than median income countries. One possible explanation for richer nations to have lower death rate is that these countries tend to have well-established health systems that have a lower likelihood of clustering and can function better under pressure. Studies have shown that older people that are at much higher risk of suffering severe consequence from coronavirus. And we can see from the scatter plot, countries with the highest life expectancies tend to have a higher death rate as well. And then here is the issue about the k-means. The k-means can give us an intuitive illustration of the relationship between factors and death rate. However, it cannot provide quantitative result. To get more detailed result, I start with a regression analysis. So this result of linear regression models shows that adjusted R squared is 45%. But the important variables such as healthcare expense of GDP and unemployment rate were not significant, which implies the multicollinarities may be present. Therefore, we decide to conduct the automated feature selections and use methods like lasso regressions in the next section, in the next PowerPoint for the further analyze. Here is lasso selections, and the results show how the shrinkage penetrated the parameters when the lambda is selecting user cross-validate against a grid of values based on the minimal MSE. As the lambda increase, the coefficient of some parameters, some predictors approach exactly 0. And here is the result of our lasso selections. The figure shows the predictors selected by lasso regression. They are such as continent, GDP per capita, life expectancies, and health care expense as a percentage of the GDP. Also, we have the random forest models. And the cross-validations give us RMSE of 3.551, which is lower than the result from the linear regression. So that is a good thing. The most important variable as shown in these figures are health-related variables, and like one economic variables is GDP per capita. Overall, the training and testing accuracies for the random forest is highly vary across models as shown in this picture. The full data set shows many countries with few deaths and few countries with many deaths. Therefore, training accuracies for countries with few deaths is higher than training accuracies for countries with many deaths. We also use a gradient boost, so which is a very powerful method in which a sequence of regression trees is built based on the residentials of previous trees and the previous graduate move towards the true value driven by optimized loss function in each tree. The result of the gradient boost, as the table shows, the performance metrics of 10-folder cross-validation use different combination of hyperparameters. So the most optimal model based on the minimized error metrics have a RMSE and MAE of 2.8 and 2.11, which is even better than the random forest. If we remember, the random forest is 3.5 something, which is already better than the linear regression. So gradient boost is the best among them. So in this project, big data analytic method were applied to understand difference in the severity levels of coronavirus among the countries. After modeling the cleaned and transforming data use various modeling techniques with cross-validation, we reach a conclusion the gradient boost is the most optimal mode in terms of the minimal RMSE and MAE, and is also selected the three most influential predictors, three most powerful predictors is like the life expectancies and healthcare as a percentage of the GDP and GDP per capita. which can make an intuitive sense in predicting the total deaths per million people. So in conclusion, we believe that countries should aim to increase the healthcare spending as a percentage of government budget and take a long-term approach on economic development to gradually increase GDP per capita and boost citizens' life expectancies in addition to implementing short-term healthcare measures such as social distances, wash hands, and mask wear in order to flatten the death rate of potential future pandemic. Thank you.